Okay, even though this is actually the first video I am doing, the first problem I'm making a video for, I'm going to say that, as always, I want you to make sure you have read the problem beforehand, even more than one time. Like sometimes it takes 2 or 3 times, reading it through to kind of digest all of the information and kind of, wrap your brain around it, okay? And hopefully you've also attempted it, thought about it, actually tried to do this without, really any assistance. So if you haven't done that at this time, please pause this video, read the question thoroughly at least once, and at least think about what you would do to solve this. All right, now that you've done that, let's talk about how this is supposed to be done, or at least one of the ways this is supposed to be done. All right, so the problem definitely talks about writing and solving a system, okay? Now, that word should jump out at you. A system of equations basically means 2 equations most of the time. It can mean more, but for us in the Keystones, it's going to mean 2 equations. So we have to create 2 equations that involve x and y. And like a lot of Keystone questions, it's extremely, extremely important to pay attention to what the x variable is supposed to represent and what the y variable is supposed to represent. So x is supposed to represent the number of small baskets, and y is supposed to represent the number of large baskets. So you got to think about, how can I make 2 equations involving x and y when they represent what they represent. So the first equation is going to be x plus y equals 8. Simply because there are 8 baskets total. It was very important to realize that there was a total of 8 baskets. And so when you do the number of small baskets plus the number of large baskets, whatever they might be, like they're unknown right now, that's why we're using variables. So whatever the number of small baskets is plus whatever the number of large baskets would be, it's going to equal 8. Okay, so that's the first equation. The second equation should go like this: 3x plus 5y equals 36. Okay? It was also important to notice that there was $36 that you spent total, and that it was $3 for every small basket, and that it was $5 for every large basket. So how does that end up being $36 total? Well, if it was $3 for every small basket and we bought x of them, okay, it makes sense to multiply 3 and x together, just like it would make sense to multiply 5 and the y variable together to get total money and everything and add all that up and equal 36. So there's the system of equations, and I guess part A is not even done until because you also have to solve. The directions say you also have to solve it. So maybe you could pause the video for a few seconds and think about how you could solve this system. Okay, now that you've maybe done that, how do we solve a system of equations? Well, giving you kind of like a big picture explanation or instruction, there's actually many ways to do this. One of the ways is to literally graph the lines of both these equations. You could get out some graph paper or whatever and graph these 2 lines. And the solution, that would be called the graphing method, of course. So, and remembering that the solution to using that method would be where the lines cross, the coordinates of where the lines cross. But there's a couple more reliable methods that are more algebraic, using algebra, using the equations. So we're going to pick one of those. One of the ways is called the substitution method, but there's another way that's called the elimination method, and I actually call it the addition method, and that's the method we're going to do. So we're going to do I'll just kind of write it up here randomly. We're going to use the addition method which textbooks and most teachers will just call the elimination method. Okay? Now the idea, I'm just going to give you kind of like a long explanation or a thorough explanation in these videos. The idea with the addition method is we want to add the equations together. So everything's got to be lined up. The x terms have to be lined up. The y terms have to be lined up. And the constants have to be lined up. Equal signs lined up, everything. Everything's got to be lined up, okay? And with this system, with the equations we wrote down, it's already lined up. So we're good to go, at least on that step, okay? But you're not going to want to add these equations together, part by part, until you know that either the x's are going to cancel out and go away for a second, or the y's are going to go away for a second, so we can, solve for x, okay? So if we were to add these together right now, it would be like 4x plus 6y equals 46. That really doesn't get us anywhere. So there's not opposites. So, obviously, again, just to kind of reiterate, 3x and 1x, not opposites. I guess one of the words you're thinking of is opposites. So 3x and x, not opposites like we would want. 5y and 1y, not opposites as we might want. So we actually, in this problem, we have to create opposites. And the way we do that is by multiplying one of the equations or both of the equations by whatever number would do the job, okay? So just kind of at random, not at random, but I'm going to choose to make the x's opposites, okay? And it's always up to you and your prerogative how you want to create opposites if you need to. So I'm going to choose to make the x's opposites, and the way I'm going to do that is think to myself, how can I make x the opposite of 3x? Well, I got to make it into a negative 3. And how would I do that? I would multiply it by negative 3. But you got to remember, when you do this, you have to multiply the entire equation by negative 3, not just the x. So the first equation will become negative 3x, just like I planned, minus 3y equals negative 24. Okay? And the second equation, sometimes you also have to change the second equation, but in this case, you don't have to change the second equation at all. You can just leave it as is, because as long as you have opposites that are going to add up to essentially 0, you can go ahead and pull the trigger on adding the equations together. All right, but the y's, negative 3y plus 5y, that's going to be 2y. Negative 24 plus 36, that is going to be positive 12. Okay? Now you have the equation 2y equals 12. Why is that a really, really good thing? Well, because this equation only involves y, and we can now solve for y. That's the whole idea. Like, ever since the start of us solving the system, it's about figuring out what y equals and what x equals. And now we're in a great position to just divide both sides by 2, just getting getting y by itself and figuring out that y actually equals 6. So that means that, what was y in the first place? The number of large baskets. So there was 6 large baskets. And if you think about maybe this original equation, how when you add the two number of baskets together, you get 8. If you want to think of it as literally plugging in 6 for y, you're going to figure out that x equals 2. Okay? So, final answer, 2 small baskets and 6 large baskets.